Welcome students. In today's video, we're going to take a look at how to create tables, graphs, and equations to model some mathematical situations. Before we get started though, do you know who invented algebra? And neither do I, but they must have been a real expert. Expert? No. Okay, you and baby are not happy with me with that one. Okay, anyway. So when we think about variables, graphs, tables, all these things, right? It's really important that we understand our vocabulary and where they go in these different comparison models we're going to be talking about. So independent variables are your x values. And when we think about our x values, they're often referred to as our input. X values are always going to be on the bottom, on the x-axis of our graph. So that's the independent variable, and that's the bottom of our this is a one-quadrant graph, so it'd be on the bottom. And then our dependent variables are always going to be, those are like our output, right? So on a table, they're going to be on the right-hand column, which is the output column, or on a graph, they're going to be on the y-axis, which is the vertical. Again, when we look at this graph, this is a one-quadrant graph, which really just means if you think about the whole quadrant plane, it's really just if you cut out the first quadrant one, that's what you're looking at here. All right, let's get into an example here where we're going to be taking a look at how to create a table, how to write our equation, and then how to come up with our graph to model a situation. So it says Kevin is taking a taxi from the airport to his home. There's a $6 flat fee for riding in the taxi. In addition, Kevin must also pay $1 per mile. Write an equation where m is the number of miles and t is the total cost in dollars of the taxi ride. Determine which variable is independent and which is dependent. Then graph the total cost for m being less than 6 miles. Okay, so there's a lot of different stuff going on here, right? When we look at a word problem like this, one of our most important things when we start is just break it down in the information that we have. So we know there's a $6 flat fee. So that means he's paying $6 no matter what to get picked up by the taxi, right? In addition, he's got to pay $1 per mile. So however many miles away from the airport he is, he's got to pay an extra $1 for that. And then now we're asked to write an equation where m is the total number of miles and t is the total cost. So they're already giving us that we have miles and cost as our variables, right? Okay, now we need to fill out a table and then we need to graph it. And before we can do either of those, we need to figure out which variable is independent and which variable is dependent. So remember, your independent variable is your x or your input variable. It is considered like the cause of whatever's happening. The dependent variable is based on that independent variable. It's the effect. So when I look at this situation, we have miles and we have cost. Well, depending on how far he goes, it costs more money, right? So the miles are the cause of the cost, right? If he's going somewhere really far away from the airport, it's going to cost him more than if he's going somewhere really close to the airport. So miles is going to be my independent variable, which is my input or x variable. So that's going to go on the left side of my table here. So I have miles, which is m. And then my dependent variable is going to be my total cost, which is t. Okay, and I can go ahead. It's really important when we're creating our graph and our table that we are using labels. Those labels are very, very, very important. So we got to make sure we're doing those every time. So on the bottom here, on the x-axis, and you're going to see I'm going to be going into the orange a little bit, but that's okay. This is going to be miles down here because that's my independent. And then on my y-axis, I'm going to put total cost. Okay, now let's take a look at some situations here, right? It says graph the total cost for M being less than 6 miles. So I know 6 is going to be my max here. So if we're 1 mile, 2 miles, 3 miles, 4 miles, and so on, away from the airport. And now if I'm trying to figure out the total cost, well, it's $1 per mile, right? And then I have to add in my $6 flat fee. So if I'm going 1 mile away, well, $1, 1 mile at $1 a mile, right, plus my $6 that it costs for my flat fee gives me a total of $7. Right, and if I do 2 miles at $1 a mile, and then I add in my $6 flat fee, gives me a total cost of $8, right, and so on. So we see that the fee is $1 per mile. So we're really just taking the number of miles and then adding 6, and that's going to give us our total cost. If it were a different cost per mile, like let's say it was $2 per mile or $3 per mile, all you need to do is multiply the miles by whatever that cost per mile was, and then add your 6 at the end. So you can just go ahead and fill these in. Okay, now each one of these data points on our table represents an ordered pair that we can then graph on our equation. So if I look, 1, 7. These are my x values, these are my y values. When we create ordered pairs, it's always going to be x comma y, which correspond with then points on our graph, really. So we're just going over to 1 on our miles and then up to 7 or whatever our thing is, right? Okay, I want to show you one thing about our graph here. So when I look at a graph like this, I see that I need to get up to 12. So if I count for my y values, I need to get up to 12. So if I count my spaces on my y-axis here, right, I have 1, 2, 3, 4, 5, 6. And I need to get to 12, right? So if I count by 2s, I can get up to 12, which will allow me to graph all those points on my y-axis. And then if I look at my x values there, I need to get to 6, and I have 6. So let's just go ahead and label those now. So it's 1, 2, 3, 4, 5, 6 on my x-axis. Then I'm going to go up by 2s on my y because I need to get up to 12. Okay, so now I just need to graph these points, right? So over to 1 up to 7. 7 would be directly in between 6 and 8. Then 2 is 8, and so on. So all I'm doing is I'm taking these points from my table that I made, right? 3 miles is $9 total cost. So I go to 3 for miles and up to 9, which would be between 8 and 10. And I'm just continuing on again, 4 and 10. So we're seeing that we have different representations here for the same information, right? We have a table and we have an equation, and we have a graph that both represent the exact same thing, right? They represent my this situation of Kevin taking a taxi. So regardless of which way we display the data, they mean the same thing, but we can do different things with them from the different information. When we look at graphs, they provide us with a visual that gives us, we can look at trend data from that, we can think about the future and what's happening with it as time moves on or as miles move on. When we look at the table, we have raw data. We have raw data points. Tables are really useful for looking at specific points in that way. They can also help us to write equations. Graphs help us give a little bit more of a visual. All right, let's do our last part here. Let's write an equation that models what's happening here.